we go. All right, so we've got why are you hitting on a yes, here we go. He does to everybody. I don't know. So phase shift. Phase shift. Phase shift is a horizontal shift, folks. Now we're going to take the graph along the x-axis. We're going to move it, okay? This means, and you can tell here, we are concentrating on this right here. That whole quantity. This is the difference. Up until now, we have had, you know, this could have been positive or negative here to show the reflection. Our coefficient in front of our trig function is the amplitude, meaning how high and how low above or below the oscillation line the curve is going to fall. And then we talked about the period, the length of the curve, and that was by the coefficient in front of the x. And then the very first thing we talked about was the number that was added or subtracted to the end of the function, which was talking about whether we move the oscillation line up or down the y-axis. So that's our vertical shift. We are concentrating on this entire quantity right here. Specifically, what is added or subtracted to that quantity. And notice phase shift right here, it's opposite from what you expect. If you have plus C, plus a 3, doesn't mean you're going to move to the right, it means you're going to move to the left. It moves in the opposite direction from what you think. Please write that down. From what you expect. Okay? Moves in the opposite direction from what you expect. Now, the phase shift moves the curve right or left. And in order to know where we're going to start or end our curve, you have to have 5 main points. And we've done that. If our period was 2 pi, let's go here. If our period was 2 pi, we started the values, those increments on our x-axis where? At 0, and then it went to 2 pi, and then we would take half of 2 pi, which was pi, and then we would find what's half of pi. What is that? Come on, y'all. Pi over 2, right? Which is half of pi. So we've got 0, 1 half, 2 halves. What goes in my next blank? 3 halves, or 3 pi over 2. And then 4 halves gives us 2 pi. We've done that already, and I told you. It becomes very, very important to you to be sure. Some of you, just a side note, some of you are not starting your curve, whether it's sine or cosine, on the y-axis. You're putting it just a little bit over. It has to start on the y-axis. And I have to take points off for that because everything that I've graphed has started. For example, if I wanted to just y equals cosine x, then it has to start on that y-axis, okay? Now, going back to the phase shift, we've got to have those 5 pieces on the x-axis, those 5 increments. If the period is 4 pi, then what's the first piece that we're going to label on that x-axis? If, if our curve is going from 0 to 4 pi, what's the next piece that I'm going to label? Half of 4 pi, which is 2 pi. We find the middle point. And then of these 2 points, we find the middle point again, don't we? So what's half of 2 pi? Pi, 1 pi. So we've got 0 pi, which is 0. 1 pi, 2 pi, what goes next? 3 pi. That's easy when it's like that. Even when the period of the function is pi, we would run the cycle, that curve, from what to what? 0 to pi. What's the midway point? Pi over 2, which is half pi. What's halfway between 0 and pi over 2? Pi over 4. And think back to that unit circle. All right, so we've got 1/4, 2/4, 3/4, 3 pi over 4, and then 4/4. Do you guys agree with that? Okay. These are things that we're comfortable with, things that we are familiar with. You guys were finding the period of real numbers yesterday. If the period was 1/5, then you had to figure out, woohoo, what's the halfway point between 1/5, 0 and 1/5? 1/10, and then 1/20th, and then 1/20th, 1/5, 1/5, 2/5, 3/5, right? No. 1/20th. That was from the assignment yesterday. But you guys got that, okay? Now, to find these increments, things are going to change a little bit. Things are going to change. We've got to add the phase shift to these increments, to these intervals, so we can graph them. So you're going to set up a compound inequality. And you're going to set up that compound inequality from this up here. We're going to take this right here, that quantity, and I want you to do this on your paper, and we're going to, that's not going to work. I sure do. All the way down. And we're going to put that bx plus c in the middle of our compound inequality. And this is going to help us to determine what the length of this curve is going to be. It's going to start, where it's going to start, where it's going to end. Okay? 0, it's going to be your beginning point. And the period that we find, 2 pi over b, it's going to be our ending point. This all has to do with, now what we have been doing, we've always started at 0, and we have gone however long that period was. And then we just mathematically, we computed, we calculated what those other increments will be. But this is a quantity that's going to be in the parentheses in your original problem, okay? How is this all going to work? How is this going to work? Let's see what's on the next page. All right, I'll tell you what you're going to have to do. Stop it. These are the instructions that you're going to follow. I had to split that up. Steps 1, there are how many steps? 5 steps, okay? Put that on your notes. Are y'all in 2 pages like that? Yeah, it is. Okay, all right. This is 5 steps to do this. 5 steps. And it's cut and dry, folks. It tells you exactly what to do. Now, my notes are a little bit different from yours. It says you got to solve the compound inequality for the range of increments. All right? Let's see how this all plays out. And I'll refer back to your notes. we're given the function y equals sine of the quantity x plus pi over 2. We go about the same stuff we've been doing, okay? So is this function going to reflect? Everybody can answer this for me. No, it's not going to reflect. What's the amplitude? I'm going to take the absolute value of what number?
1.
Of 1, which is 1. Phase shift, I'm going to come back to that. Okay. Is there a vertical shift for this? No. No vertical shift, which means my oscillation line is where? Is at the x-axis. Make yourself a note. And then I always put the interval at the end. Folks, this has to do with the period, okay? The period of this is going to be 2 pi over what? What coefficient's in front of your x? 2 pi over 1, right? Okay? So our period is 2 pi. Now, according to those instructions, we would set up a compound inequality. Now, I want you to see how this will work. So it'll run from 0. I have to put this compound inequality, or this quantity, in my compound inequality. And then what was my period? My period was 2 pi. This is another way to figure this out. We know the right answers. We know what they're supposed to be, but I want to show you how there's another way to find the answer, because it's not always going to be nice 2 pi, okay? Watch what we do. If you remember from solving compound inequalities, we want to isolate our variable, correct? So I'm going to subtract pi over 2 from everything. Okay? That's going to give me negative pi over 2 less than or equal to x less than or equal to, what are we going to do? Folks, here's what you're going to do. You're going to get your calculator. Well, in a minute. You're going to get your calculator. Get your calculator. All right. Now, if fractions give you a fit, you're going to use your calculator. And we're going to take 2 and we're going to subtract what from it? 1/2. How do you know it's 1/2? Because it's 1 pi over 2, correct? So, now, am I going to throw a decimal up in my problem? Absolutely not. And I'm telling you, some of you are like, why is she showing us how to do this? Because some of y'all cannot do these problems without this stupid calculator. I say that with love, okay? That's going to give me 3 pi over 2. Y'all with me? All right, 3 pi over 2. Now, what does that mean? That means that my graph, my function, my curve, is going to shift which way on the x-axis? Is it going to shift to the right or to the left? How do I know? Go back. Is it going to shift to the right or to the left? It's opposite what we think. So it's going to shift left. What's our increment? Just put shift to left, okay? So here we go. Check this out. We have our graph. You ready for this? All right. Our oscillation line is the x-axis. Do you guys agree? That doesn't change. And folks, I have to see the x-axis. I do not care if your oscillation line is at x equals or y equals 10. I have to see your x-axis. Okay? I'm taking points off every single time. You don't label it appropriately. Is my curve going to start at 0? Yes or no? But it's going to shift to the left. It's going to shift to the left. So my starting point is no longer 0. Remember that your beginning point is now going to be at negative pi over 2. So it's going to be negative pi over 2. And if it's negative, of course, it's over there on the negative side. Okay? Now, how are we going to get those other values? I have to have 5 pieces. Okay? I'm going to end up at 3 pi over 2. How am I going to get my interval? Do you see right here where I have the interval? Put a star by this. 1/4 of the period. You're going to do this every time. Okay? Why am I choosing 1/4 of the period? Because that's telling me my increment. 1/4 of the period gives me the increment by which I'm going to add. Okay? So I'm going to say negative pi over 2 plus my interval. What's negative pi over 2 plus pi over 2? 0, right? Calculator. You guys are just looking. Okay. Negative 1 divided by 2 plus 1/2 is 0, correct? Okay. 0 plus what? Plus pi over 2 is pi over 2. Pi over 2 plus pi over 2 is, what's 1/2 plus 1/2? Pi. Okay, and if you need to put up here, put 2 over 2. So you'll know it's pi. And then, folks, what's 2 pi over 2 plus 1/2? 3 pi over 2. Do you see what I'm doing, yes or no? Okay. Now, mark these spots. I told you it would be very important to you later to label your x-axis. And it's very important that you label it appropriately. My oscillation line, now everything's the same, okay? My oscillation line is the x-axis. Is there an amplitude? My amplitude is 1. I've got the sine curve, folks. Where does, now be careful. Remember, the curve has been shifted to the left. So where does my sine curve start? At the what? At the negative pi over 2. All right, now, here's something else you need to do. You need to label your y-axis as well. Because my curve, and folks, be very meticulous about this. Be very, very particular. It has to go up and start curving downward at the 0. It has to come through pi over 2, down here at pi, and then back up at 3 pi over 2. Do you see how you've got, now here's what you need to do. Some of us will need to draw our curve, and then we'll need to label our x-axis, because some of us have difficulty drawing that smooth curve. And then we just do, okay? Some of you will be able to label everything and follow these guidelines every single time, okay? Did my curve follow the amplitude? Am I 1 unit above and below the oscillation line? Yes or no? Yes. Okay? You just moved a curve. You abided by all the criteria. The amplitude, the period is still the length of 2 pi. You've put in the increments like you should because this has been shifted to the left. Blank stares. Wow. Here we go. Yep.
Okay. Whenever you're describing how you went from -5 over 2 to 3 pi over 2, why can't we just, well, we know that 0 comes after -5 over 2, and then we knew that 3 pi over 2 is your last thing.
I don't know. Would be a great question for everybody, but see, people aren't really paying attention, so I'm going to have you ask that question all over again because it's going to be relevant to every person in this room.
Why did we have to take it the hard way out to find what the 3 points that we were missing? If we knew that it started at -pi over 2 and it ended at 3 pi over 2, why couldn't we do it just like every other time?
Because it's not going to be that easy every other time.
Oh, okay.
It's not always going to be that easy.
Then how do we apply that?
You're getting ready to find out. Getting ready to find out. Just be patient. Okay? Here's another one. Look at cosine. X plus pi over 2. All right, now you know what the interval is going to be because this thing is going to move which way again? It's going to move to the left. And it's the same thing we just had. Okay? So you know what it has to be. We've got plus pi over 2. Plus pi over 2. The cosine curve, first of all, just by looking at it, is it going to be an up cup or a down cup? A normal cup. Why? Because it's positive. So it's going to look like that, right? It's going to look like a cup. But it's going to be shifted to the what? To the left. All right, I want you to try that one yourself. You got to find all the stuff and you have to graph it. Yes. Because 2 minus 1/2 is 3 over 2. Does this reflect? Yes or no? No. This is a cup. All right. I'm going to put that because if I don't, I'm going to make a careless mistake and I'm going to draw a sine curve every single time. Because sine curve for me is easier to draw. I don't know why, but it is. Amplitude. What's the amplitude? The absolute value of what? 1, which is 1. Okay, so it's going to go 1 above, 1 below. Period. What's the period? 2 pi over who? 1, which is here in front of the x, which gives me 2 pi. Now I'm going to find the interval, which is 1/4 times that what I just found, 2 pi. Okay, which is 2 pi over 4, which is pi over 2, right? So that gives me my interval. I know what this is because of the last problem. But it's not always going to be that way. Okay? Phase shift. Which way is this thing going to shift? To the left. And then I put my interval right there and I didn't need to. Okay? Is this going to have a vertical shift at all? No vertical shift. None. My oscillation line is at the x-axis. And again, that's just a note to me. Okay? Where does the compound inequality come in? It comes in here. Once I find the interval, then I'm going to take, before I do anything else, and I'm going to have 0 is less than or equal to x plus pi over 2, less than or equal to, period, which is 2 pi. And then I'm going to get negative pi over 2. I realize I've already done this, but it gives me my beginning point and my ending point. Do you guys agree with that, yes or no? Okay. Because where does our curve normally start? At 0. That's why it always starts with 0. It always starts with 0. This is our phase shift quantity. And it always runs to whatever you have just found your period to be. Okay? Because your next example is not going to be like this. Okay? Now we're ready. So here we go. I'm going to highlight or dot my oscillation line. My amplitude is 1. I'm going to shift this to the left. Where's my beginning point? At negative pi over 2. And I know because of my last problem, let's see, negative 1/2, 0, 1/2 pi, 3 pi over 2, right? Okay. From my last problem, I know those are going to be my x values. And it's going to start here. And this is what I have to think about. It's going to go through 0. My minimum point's going to be here at pi over 2. It has to pass through pi. And then my maximum value will be there at 3 pi over 2. Questions? How many of your graphs look like that? Your curves look like that? Good. You have to be very specific. Questions at all? Let's jump on the next one.
So the graph is always going to run through the, like, the center and the first point?
It's always going to, our cosine curve is going to run through, it will go through the x-axis at your second increment and fourth. Yes. Because what if you had to name these ordered pairs? Think about that. What would this ordered pair be? Just throwing it out there. 3 pi over 2, comma what? 1, right?
Yeah, because it's just like on a normal graph, yeah.
So you have to be very careful. That's why I want your, I know I'm being nitpicky. I told Jesse, erase some little things past them points. Don't have your curve going past those points. Don't do it, okay? And that is me being nitpicky, but we have to be nitpicky about this. Let's go to the next one, which must be down here. Oh, yeah. Now, and again with the cosine, because it's, for me, the most difficult, okay? Hey, by the way, you're not going to have homework, so just look at the clock and go, okay, good. Okay, here we go. Same thing we've been doing, okay? Is this going to reflect? No. Amplitude. There we go, thank you. 2 pi over who? Which is 2 pi. What do I need to find? I'm telling you, if you do this every time, find the interval. So, my interval again is going to be 1/4 of 2 pi, which is pi over 2. Do you guys agree? Okay. All right, so I took care of the period. Let's take care of the phase shift. Phase shift. Which way is this thing moving? It's going to move to the right this time. This right here. Yep, and that's what it says in the very first part of your notes. Okay? It's going to go in the opposite direction of what you think.
Why is that?
Because you know what? When you graph the absolute value function, or if you graph a parabola that's in standard form, meaning it's in parentheses, anytime you have anything in a quantity, it goes in the opposite direction of the sign, the opposite of what you normally would think. And it does it for absolute value, it does it for quadratics, it does it for this. Probably. Okay? That's the only pattern I can figure out, because it's always like that for other functions. Phase shift, we got that. Does this have a vertical shift?
No.
No vertical shift. So that means my oscillation line is where? And that's a note for me. Okay. Holy crap. Wow. Go to your compound inequality, and I would do the work up here beside. It's going to run from 0 to where? It's going to run 0 to the period. Not this time. Just watch. What's your quantity? Your quantity is the parentheses, x minus pi over 4. Less than or equal to, what's our period? 2 pi. Earlier, it was a piece of cake. This is when it gets kind of hairy, okay? Add pi over 4 to everything. And we get pi over 4 is less than or equal to x, which is less than or equal to, that's 8 over 4, 9 over 4. 9 pi over 4. Now, oh my God, how does she do that? Get your calculator out and add 2 plus 1/4. Math frac, and it gives you 9/4. Okay? Everybody clear? All right. Now, this is my suggestion. Your beginning point is pi over 4. What is your interval? That's my first point. My second point is don't tell me what it is, tell me how to get it. Because people can't see your work in your head. How are we going to get it? We're going to take pi over 4, which is straight from the first point, plus, what's our interval? Pi over 2. All right, calculator. Braden, will you cut that on for me? Thank you. All right, so 1/4 plus 1/2. I hope that's 1/4 plus 1/2. Oh, what's it going to be? A number. Did you just say a number? Math frac. 3/4, right? All right, so that means my second point is 3 pi over 4. Your third point is going to start with 3 pi over 4, and we're going to add what to it? Pi over 2 again. That's why we find our interval. So what's 3/4 plus 1/2? Calculator. Everybody can't do it in their head. Be patient. Be patient. Breathe. Just breathe. It will put you in a Zen-like place where you need to be. And it's going to put me in one too, which is where you need me to be. Okay. On. 5 pi over 4. Now we got to find our fourth point. Where do I start? 5 pi over 4. Plus who? Pi over 2 again, which is going to give us 7/4. Odd. Are you seeing a pattern here? 1/4, 3/4, 5/4, 7/4, then 9/4. We know we're right. Look at the R. Okay? Now we're ready to graph it. You're still no, you don't have to put numbers over there, but you have to draw the axis. You're drawing an axis. Okay. If you have a y-axis, won't we have an x-axis? Yes. Yes. Okay. All right. Here we go. Yes, ma'am. How? Okay. All we're doing is this. Copying the numbers down. But you can't always do it the other way. It's not always going to be that easy. Because what's going to happen when I throw up for your beginning point, it's going to be negative 5, 6, negative 5 pi over 6. Then what are you going to do? And your interval is like 2/5. You're going to add. That's what we're doing. That's all I'm doing. It's just in a different format. If you need to do it this way, then do it that way. I'm just doing it this way. Okay? Because what am I doing? I'm providing you with a pattern to follow every single time for all of these problems. This right here for you may be this, Megan. And if that's what you need to do, you do that. Okay? I'm going to do it this way. Okay? But I'm totally fine with you doing it like that every time. Okay? I'm fine with that. Does that help? Okay, here we go. Now we got to graph it. All right, so where do we start? Pi over 4. 3 pi over 4. 5 pi over 4. 7 and 9. Oscillation line was the x-axis. There it is. What was the amplitude? 1, and its cosine. So is this a up cup or a down cup? Up cup. All right, so it's going to 1, and it's going down to negative 1. Where does it start? At pi over 4. Okay, there you go. It's going to go down through 3 pi over 4. Our minimum value is at 5 pi over 4. Come back through at 7, and up at the top, 9 pi. How about it? Easy? Easier? Give it a chance. Give love a chance. Not a Beatles song? Or a line out of a Beatles song? Maybe not. I didn't. Give peace or love and love a chance. Questions? Do what? Just 2. 2 you better do. Quit whining. Love you. Then don't do them. Doesn't matter to me. There you go.